Welcome everybody. In this video, we are going to look at final year 3 student capstone project from Nanyang Polytechnic, Diploma in Infocom Media Engineering, Media Technology and System, EGL314 project. The project titled Sensory Observation Ninja Immersive Challenge, Sonic, is a semester-long project where Year 3 Media Engineering students will spend their time exploring the use of sensors, embedded systems, programming to integrate together with commercial AV equipment. So without further ado, we are going to look into their project. So we have reached our first station, and this is
Team F. We are Team F, comprising of myself, Joven, Samuel, and Kenwei. Our game here is called The Range, and here are the mechanics of the game. We have three sides and three boards, left, center, and right. You'll hear sounds coming from each of the sides, and you have to hit the correct board depending on which side it comes from. For example, if you were to hear the bamboo stamp coming from the left side, you would hit the left board. Same goes for the center and the right. That is a brief summary of the game. I will now be passing my time over to Samuel for the hardware side.
So for this station, the hardware will include a Raspberry Pi, piezo sensors, and also some GPIO jumper wires, as well as some 3D printed Ninja Stars that are used to throw at the targets. Together with the 3D printed Ninja Stars, we have 3 sensors located in the left, center, and right board. We also created a case to cover the Raspberry Pi so that when the Ninja Stars are being thrown at the targets, it does not damage the Raspberry Pi.
Moving on, I'll be sharing to you about the system side of the game, where it's consisting of the Garayan MA3, which is a lighting console, the Reaper DAW, which is a digital audio workstation, as well as the Lisa controller, where it controls the audio soundscape of the game. This is all done through Raspberry communication, where it sends a OSC command to the different lighting and audio equipments for you to enjoy the game.
Alright, so if you are joining us on the end semester showcase, please visit Station 1 where you can practice your accuracy in the range. Moving on, we'll move on to Station 2. Right now we are at Station 2 and this is Team
A! And welcome to the Blindfold Challenge. And here we have Ryan, Travis and myself, Cheryl. This game involves 2 ninjas. So what I'm stepping on right now is the terrain, where the purple light represents the start and the green light represents the end goal. And the light that I'm stepping on right now represents the obstacles. And Ninja 1 will walk through the shadows. And here's the catch. Ninja 1 will be blindfold and will be guided by the sound of the wind by Ninja 2. And now I'll pass the time to Travis.
Okay. Hi, I'm Travis. Let me talk about the hardware behind this game. Inside this box, which is our wind totem, it's actually a MIDI controller, which is this. So currently, whatever you see here, it's a 3D printed joystick courtesy of Mr. Fu, and it's actually connected to one of the knobs over here, which is also spinning the knob. And what happens is, when a person spins the knob, it controls where the sound of wind is coming from the actual game through a Raspberry Pi. So what happens is, this is connected to Raspberry Pi, which is this little mini computer over here, and by one turn of the knob, it sends multiple commands into our lighting console, as well as our Reaper, our digital audio workstation, and also a Lisa controller, which is our audio soundscape. And that's basically it. Now I'll pass the time to Ryan, who will explain the software behind the game itself.
So, you must be wondering, how does our amazing game works? So now I'll explain it to you. So firstly, when the player turns the knob, it sends the values of the knob to our Raspberry Pi. And from our Raspberry Pi, we go through formulas and filter out the correct values, which will then send the values to the ELISA through OSC. Now I would like to share about our game GUIs. So we have 2 GUIs, which is the participant GUI and the master GUI. So we created the GUI through Python, and when each button is pressed, it will send out individual values through OSC to our Grand MA and our ELISA to control lighting and sound. Yeah.
So if you're looking for a game to test your teamwork, you can visit the Blindfold Challenge during the end semester showcase. Now we'll move on to Station 3. In our next station, we have Team E!
Hello, I'm Victor. This is
Jerome,
Daniel. So our team is called The Art of Hearing. So our game is mainly about solving and opening a number lock using the sound that you hear specifically from one out of 3 area of the classroom. So the sound will be coming out of one of the 3 speakers, and based on where you are standing at, you have to pick up those sound, write it down, and use the legend to translate into a number. And when all 3 numbers are gathered, you guys can put it together to solve the number lock. So now, I'll give the time over to Jerome to talk about the hardware.
Hi, I'm Jerome, and I'll be explaining to you about the hardware side of our project. The number lock consists of a touch panel which is connected to a Raspberry Pi, which is powered by a power bank inside. The Raspberry Pi is able to wirelessly control the Grand MA3, which is our lighting console, and Reaper, which is our digital audio workstation. And also, it is able to control lastly Eliza, which is our soundscape engine. Yeah, I will now pass it over to Daniel, who will explain to you about the software side of our project.
Okay, I'm Daniel, and now I'll be sharing about software side. So this project uses Python and Open Sound Control, or OSC for short, to control the various AV equipments around the classroom. As shared by Victor earlier, players will need to listen to the various sounds coming from the different directions, and based on the sounds, which is either a high or low sound, we'll have to decipher various number combinations to unlock the number lock.
So, if you want to take on the challenge to decipher the number to unlock the number lock, please visit Station 3, Team E. With that, we'll move on to the next station. In our next station, we have
Team B. So welcome to our station, Reaction Training. We are Team B, and my name is Alastair. He's Isaac, Kevis, and Qing Feng.
So now I'll tell you about the game. The game is simple. Deflect the projectiles in time. How do you do that? You hear one of the audio cues from one of the directions, and you press the button for the corresponding direction. So one of these audio cues could be the ninja star, the bow and arrow, or the kunai or knives. Be quick, or you might get defeated. So I'll pass on to Kevis to explain about the hardware.
In our game, we have a MIDI launch pad, a Raspberry Pi that is having its power supplied by a power bank inside this box that is used to facilitate this game along with the lighting fixtures and the speakers around the room. Software-wise, I will now hand it over to Jin Feng now to elaborate more on that.
Thank you, Kevis. So for our game, using the launchpad will send MIDI messages to the Raspberry Pi. The Raspberry Pi will send messages through OSC to Reaper, Eliza, and Grand MA3 to control the lights and sound to create our reaction training game.
So, if you want to challenge your reaction time or train your reaction time during the end semester showcase, please visit Station 4, Team B. And with that, we'll move on to our last station. In our last station, we have Team
C. So our station is called the memory sequence. So my name is Chen Feng, this is Dick, and this is Lennon. So the objective of the game is to test your auditory and memory skill. And through memorizing a set of incoming beats from different directions in a specific order. And after memorizing, players are supposed to input the correct order so that they win. And if they lose, they will be punished to smoke. We have 2 levels, easy and hard. The easy consisting of 2 directions and the hard level consisting of 4 directions. Now I will hand over to Dick to explain the hardware.
So for the hardware, we have a launch pad that is connected via USB cable to a Raspberry Pi, which is powered by a power bank. The Raspberry Pi is in charge of communicating with Reaper, Digital Audio Workstation, Eliza Studio, and Grand MA3. The Reaper is our digital audio workstation, and for Eliza Studio, it consists of Eliza processor and Eliza controller. These are in charge of our soundscape. We also have Grand MA3, which is a lighting console that controls our lighting system. Now I'll pass over to Lennon to explain the software.
So, the launchpad communicates with the Raspberry Pi through a protocol called MIDI,
And afterwards, the Raspberry Pi communicates with just about everything else, GrandMA3, Reaper, Eliza, through another protocol called Python OSC. Afterwards, they are then communicating with the hardware side of things, the speakers, the lights that you see above, and that's how our station is powered. And with that, I'd like to conclude our station and hand over the time to Mr. Fu.
So, if you are interested to join us on our Sensory Observation Ninja Immersive Challenge or Project Sonic, do join us at our end semester showcase on 14 August at Nanyang Polytechnic. So with that, thank you for your time. Goodbye. Bye-bye.
Bye.